We're going to begin evaluating limits analytically, and there's multiple techniques to use. Let's take a look at some of these examples. You can see in the text at the top of the page that there's many techniques that can be used to evaluate limits analytically, but the first thing we should do when evaluating limits is to check to see if direct substitution works. So let's take a look at example 1, part A. If we take -2, we're talking about the limit of x squared as x approaches -2. If we take -2 and substitute this in for x, you get -2 squared, which equals 4. I hope we have a real number answer. That's our limit. Pretty straightforward. If we look at part B, we're talking about the limit of 6 as x approaches 7. Well, there's no variable to put 7 in place of. This limit is just 6. Keep in mind, we're saying that in part A, our function is y equals x squared, and in part B, y equals 6. If you look at the graph of y equals 6, it's a horizontal line where y is always equal to 6. So y approaches 6 from both sides, no matter where we're at. Now, you know things aren't always going to be that simple, so let's go take a look at example 2. Example 2, we're going to use one of our first algebra techniques. When direct substitution fails, we're going to use a factor and cancel technique. Let's take a look at part A. Part A, we need to rewrite this limit. So let's write the limit as x approaches 1. Okay, I'm sorry, you don't know that we need to rewrite this yet. Let's try direct substitution. Let's put 1 in place of x. So 1 cubed minus 1 over 1 minus 1 is 0 over 0. This is indeterminate form. Direct substitution fails because we have 0 in the denominator. We cannot divide by 0. So direct substitution fails. Now we need to use one of our algebra techniques, one of our tricks. We can use the factor and cancel. So in the numerator, we have x cubed minus 1. That's a difference of 2 cubes. Factoring this difference of 2 cubes will give us x minus 1 times x plus all over x minus 1. Now, the nice thing about this expression is that factoring allows us to take a factor of x minus 1 and cancel another factor of x minus 1. We're left with the limit as x approaches 1 of x squared plus x plus 1. Okay? Well, now direct substitution works. Put 1 in place of x. And you see this limit is 3. Yes, we do have to write limit every time we go from one step to the next until we take the limit. Okay, moving on to part B, there's a similar problem. If we try direct substitution, we're going to get -3 squared plus -3 minus 6 all over -3 plus 3. 9 minus 3 minus 6 is 0 over 0. Once again, we're in indeterminate form. Direct substitution fails. So we're going to use our factor and cancel technique. We'll take the limit as x approaches -3. Factor the numerator. Let's see, we'll get x, let's think about it, x plus 3, x minus 2, all over x plus 3. Once again, this works out nicely because the factor of x plus 3 cancels the other factor of x plus 3. And we're left with the limit as x approaches -3 of x minus 2. Now we've got rid of the x plus 3 on bottom. Now direct substitution works. We'll have -3 minus 2, which is just -5. Now in class we had a discussion about these and their graphs a little more. So if you missed class and you're watching the video, that's great. I hope this is helpful. But we also need to have a little discussion about these graphs and what these limits tell us about the behavior of a graph. So thanks for watching. I hope this video was helpful. The next video will involve some other algebraic techniques. Good luck on your practice problems.